Have you ever wondered what makes your computer smart? It's not magic, it's the Central Processing Unit, or CPU for short. Think of the CPU as the brain of your computer. It handles everything from opening programs to playing games. CPUs are incredibly complex, with millions, even billions of tiny parts called transistors. These transistors are like tiny switches that turn on and off, processing information in the blink of an eye. Making a CPU is a delicate process that requires incredible precision. Even a tiny mistake can render the entire chip useless. The journey of a CPU begins with a surprisingly common material, sand. Sand contains silica, which is the source of the element silicon. Silicon is a semiconductor, meaning it can conduct electricity under certain conditions. This property is what makes it perfect for making transistors. The first step is to extract silicon from silica. This involves heating the silica to extremely high temperatures in a furnace. The result is pure silicon, ready for the next stage of its transformation. The purified silicon is then melted down in a special furnace. A tiny seed crystal of silicon is dipped into the molten silicon and slowly pulled upwards. As it rises, the molten silicon solidifies around the seed crystal, forming a large cylindrical ingot of pure silicon. This process is called the Czochralski process, and it's crucial for creating a single continuous crystal structure. This uniformity is essential for creating high-quality CPUs. The silicon ingot, now cooled and solid, is sliced into thin, round wafers. Think of these as silicon pancakes. These wafers are incredibly thin, often less than a millimeter thick. Precision saws with diamond blades are used to ensure the wafers are perfectly flat and uniform. After slicing, the wafers are polished to a mirror-like finish. This ensures a perfectly smooth surface for the next stages of manufacturing. Any imperfections on the wafer's surface can ruin the entire chip. Now things start to get really interesting. This is where we begin building the actual circuitry of the CPU. The first step is called photolithography. It's like using a stencil to create intricate patterns on the wafer's surface. A light-sensitive material called photoresist is applied to the wafer. Then a mask with the desired circuit pattern is placed over the wafer. Ultraviolet light is shone through the mask, exposing the photoresist in the areas where the circuit will be built. Section 6. Etching away the layers. The exposed photoresist is then washed away, revealing the underlying silicon. Chemicals are used to etch away the exposed silicon, creating trenches and patterns according to the mask's design. This process is repeated multiple times, layer upon layer, to build up the complex three-dimensional structure of the CPU. The precision required in this step is mind-boggling. The features etched onto the wafer are incredibly small, often just a few nanometers wide. That's smaller than the width of a human hair. Section 7. Building up the CPU. Once the etching is complete, it's time to add other materials to the wafer. This process, called deposition, involves depositing thin layers of various materials like metals and insulators onto the wafer's surface. These layers are crucial for creating the different components of the CPU, such as transistors, capacitors, and interconnecting wires. Deposition methods vary depending on the material being applied. Some common techniques include sputtering, chemical vapor deposition, and atomic layer deposition. Each method ensures precise control over the thickness and uniformity of the deposited layer. Section 8. Polishing to perfection. After each deposition step, the wafer undergoes a process called chemical mechanical polishing, or CMP. This is like using superfine sandpaper to polish the wafer's surface perfectly flat. CMP ensures that each new layer of material is deposited on a perfectly smooth surface, preventing any imperfections that could affect the CPU's performance. CMP is a critical step in ensuring the smooth operation of the billions of transistors on the CPU. Even the tiniest bump or imperfection can disrupt the flow of electricity and render the chip useless. Section 9. Creating the thinking machine. With all the layers in place, the individual CPUs, now called dies, are cut from the wafer using a diamond saw. Each die is then tested rigorously to ensure it meets the required performance and quality standards. Faulty dies are discarded while the good ones are packaged and prepared for use. The packaging process involves attaching the die to a substrate, which provides mechanical support and electrical connections. A heat spreader is often placed on top of the die to dissipate heat generated during operation. Finally, the entire package is sealed to protect the delicate circuitry inside. And there you have it. From a simple grain of sand to a complex microchip, the journey of a CPU is a testament to human ingenuity and our ability to manipulate matter at the atomic level. The next time you use your computer, take a moment to appreciate the incredible engineering marvel that is the CPU, working tirelessly to bring your digital world to life.